Hello and welcome, everyone. Hope you had a great start to the year. Wishing each one of you a very happy new year on behalf of the Customer Enablement team. We are super excited to have you all here for the fourth season of our Day One and Beyond series. This is going to be an exciting season as we are going to add sessions on many new topics. So today we are kicking off the series with the first session, and we'll be back same time every first and third Tuesday till the end of this year. What you see on your screen right now is a quick poll on how much experience you have with cloud. Anyone who has joined us for these sessions before will recognize that we designed these sessions with you, our users, in mind. We designed the content based on your feedback and requirements. So please go ahead and answer the poll. We have about 78%, 80% so far. And maybe we can close this now, Mike. And if you would take a moment to answer another poll to let us know what kind of topics you would like us to cover. Select the topics you're most interested in so we can add sessions on new topics based on your feedback. And these will be in addition to our regular quick start sessions that we do as part of our regular series. We always appreciate any feedback that you can give on what topics interest you the most. And while you're doing that, for those of you who are new, let me give a quick overview of this program. These Day One and Beyond sessions will take you through a series of topics and activities related to understanding Oracle Cloud and building out on Oracle Cloud. Day One and Beyond is hosted on Cloud Customer Connect, which is our Oracle community forum for end users. If you haven't already, I invite you to create a free account on Cloud Customer Connect, join in discussions, ask questions, and look for upcoming events on various topics. My name is Renu Bhatt. I'm a TPM with the Customer Enablement team. And today I'm joined by Anand Prasad, Master Principal Cloud Architect, and Brandon Allaire, Cloud Engineer here at Oracle. We have our favorite expert, Creighton Swank, joining us too. And before I hand it over to presenters, a quick reminder to use the Q&A box down at the bottom of the screen for any questions throughout the session. And any questions put in chat, I'll ask you to move over to Q&A box because that's where people are going to be looking to answer questions. We are also recording today's presentation. If you have colleagues who weren't able to make it today, or if you would like to come back and check on something about it, we'll have the replay posted up on the Customer Connect forum. That's quite a lot from me today. So Brandon, please take it away and we can close the poll. Thanks,
Renu. Hi, everyone. My name is Brandon Allaire. I'm a cloud engineer here at Oracle on the Customer Enablement team. And today I'm joined with Anand and Creighton. If you guys want to introduce yourself before we begin.
Thank you, Brendan. This is Anand Prasad. I'm a cloud architect at the Customer Enablement team.
Awesome, and thank you all. Creighton Swank, I'm a field CTO aligned to the manufacturing industry, but super deep technical expertise kind of across a number of domains from data center design and migration to operations. I've also got some expertise in other cloud providers, so I'll do a little bit of comparisons and interjecting kind of some industry context as well as maybe some sort of, kind of cloud foundational content as well. But looking forward to the session.
Awesome. Thanks, Creighton. Thanks, Anand. All right. So here's a look at the agenda of what we're going to be covering today. Essentially, this is a 101 session where we cover a wide range of the different service offerings that are available within OCI. And then at the end of the session, we will have a demo where we jump into the Cloud Console. And Anand's going to take us through spinning up a virtual cloud network and provisioning a compute instance. As Renu said, if you have any questions throughout the session, just feel free to drop them in the Q&A box. All right, so before we jump into any services in particular, we like to explain the shared responsibility model. So, typically with an on-premise environment, the customer or end user is going to be responsible for managing and maintaining everything from the user access and identity all the way down to the physical infrastructure, the hardware, the servers, the cooling, maintaining the building, the data center. As you step into a cloud service, provider model, there's different levels of service. We have infrastructure as a service, platform as a service and software as a service. With infrastructure as a service, a good example of this would be like a virtual machine running within OCI or a bare metal server. And Oracle is going to maintain the physical infrastructure. The server is going to be running within one of Oracle's data centers, and they manage, the underlying hardware all the way up to the virtualization. And then as the customer, you're going to be responsible for managing and maintaining the operating system, the applications that you're running, the data that you put in, and then the user access and identity piece. As you move over, we have platform as a service. And a good example of this would be like our Oracle Analytics Cloud or Oracle Integration Cloud. Again, we're taking an additional layer and placing that on the cloud service provider, and their responsibility then becomes the operating system as well. And then finally, we have software as a service, where as the end user, you're just going to be managing and maintaining the user access and identity, and then also the data that you put into the application. And, Oracle is going to go ahead and actually maintain the application itself. Good example of this would be one of our Fusion ERP applications.
And just to jump in here real quick, one of the main benefits of kind of that shift right towards kind of the managed services is really to lower the operational complexity and kind of help you use your resources in the form of staff and development time and operations time to kind of focus on more value-added work. So, focusing less on patching and managing operating systems and focusing a lot more on, the business implications and kind of work that actually adds value.
Yep. And this picture here is Oracle's ecosystem. So we have a wide variety of different offerings. Today, we're going to be focusing mainly on the bottom section here. So compute, storage, networking, some database offerings. But essentially, we do have a broad suite of services ranging from, compute all the way to security, database, monitoring. There's many different solutions that we have within Oracle.
Yeah, in all of these services, I think that the strength here is kind of the interoperability of these services. So we've got, kind of a complete application portfolio. We've also got these individual services. But the nice thing about it is, as you start to deploy these services, you end up with deploying resources in the cloud that can access through, encrypted channels very easily without having to kind of reinvent wheels. And you can do it iteratively. So if you build a compute application, you've got a service that's running out there, an instance that's running, very easily plug in the load balancing component. And then if you need access to additional storage, it's really just policy language. You don't have to go procure a server and wait for that sort of thing to be provisioned and deployed. It's all about kind of click button deployment. So these services are built to tie in with each other and integrate natively, giving you kind of that ability to, just kind of click button deploy integration patterns that make these services communicate more effectively, all while being secure and scoped so that you prevent unnecessary access both internally and externally.
Yep. And moving on here, we have a map of all of Oracle's regions. So we just added a new commercial region within Chicago. But as you can see here, we do have a pretty broad footprint that spans across the globe.
Brendan, can you please comment on this offering from OCI with so many different regions enabled? How customers can take advantage of it, and what are the use cases they can take advantage of it?
Yeah, so typically, you're going to want to deploy your applications and workloads closer to the end user to minimize latency. And, let's say you have users in Australia, you might want to deploy your application or your workload, in Australia. And we do have some different things you can take advantage of, like traffic management steering policies that will kind of, assist and steer the traffic to the location of the application that is closest to the end user.
Thank you, Brendan.
Brandon, one more question.
Sorry, go ahead.
How does having two regions, two data centers in one region help?
Two data centers in one region. So I guess if you wanted to design, your workloads or your applications for high availability or disaster recovery, you could spread the servers across the different data centers and, set up failover capabilities with our solutions.
Thank you.
And to kind of double click on that a little bit as well, right? It's all about high availability and blast radius, right? You want to build and deploy workloads in the cloud that don't have a kind of single point of failure. So deploying across multiple components within multiple data centers within a region gives you that protection, as we're seeing kind of on pictures here.
Yeah, and that kind of brings us into our next point here. So typically, we have our regions, and that's like the geographical location of where our data centers are located. And typically within a region, we'll have, approximately one or more availability domains. And these availability domains are data centers. Within a particular, data center or availability domain, we have the concept of fault domains, and these are groupings of hardware and infrastructure that don't share underlying resources. So if one of these fault domains were to, go down or have an issue, the other fault domains could continue to run unaffected within that region. All of the traffic between these availability domains is going to be encrypted, and they're also, isolated from one another and very unlikely to fail simultaneously. All right, so we talked about the data centers, and on top of that, we have our physical network. And this is not oversubscribed, so you don't really have to worry about noisy neighbors. We also have the concept of off-box virtualization, and this is unique in the sense that it allows us to put the virtualization out of the physical box and actually into the network. Essentially, it means that virtualization is no longer committed into the hypervisor, and it's actually engineered into the network outside of the physical box. So it gives us nearly zero performance overhead.
Yeah, so it's more secure because we've offloaded that to kind of purpose-built hardware, thus, making it sort of, I'll never say impossible when it comes to security, right? But it makes it a little bit more challenging because you don't have all of the other layers that you would associate with a traditional hypervisor. So no things like web servers and notification components and all of that. So not only is it more secure, that also offloads the encryption and some of the other networking overheads so that you basically get the resources within OCI that you're paying for 100% of the time. You don't have to worry about kind of that, well, I've got 20% of my CPU is going to network activity, because that's all offloaded to purpose-built hardware.
Yep. And then also we have this top layer here. So this is many of the different services that we have within the console available to us. Within our data centers, we have compute servers, bare metal virtual machines. We have different database systems that we can run, Exadata, DBCS, or if it's, an open source database that can be ran on Oracle as well. Some different storage options like block storage, file storage, networking resources like, our virtual cloud networks, load balancers, VPN if we wanted to set up some connectivity to on-premise. And then also many different security tools that we'll be talking about in the upcoming slides. All right, so when you first get your Oracle Cloud account, you're going to, select a region that's going to be your home region. And then within that region, you can see we have a tenancy here, and that's this dotted line. So essentially everything that you do within, this data center, when you deploy an instance or create a network, it's going to be provisioned within your tenancy. And, as we kind of move through this presentation, we're going to be building out this architecture a little bit more. So as we add some services and we talk about more services, you'll see how they fit into this architecture and essentially an example of how they could fit into your tenancy. All right, so now we'll talk about some security services. And Oracle does have a wide offering of many different security services. And this visual here shows many of them listed from different domains like identity all the way over to the internet and edge. So identity is a little bit lower on this visual because it really does come into play with all the different services, including the security services. We have identity and access management, and that's about managing user access and identity, assigning them privileges. And in order to interact with any of these other services, you're going to need to assign your user to a group and then make sure that they have the appropriate policies written and permissions granted to actually interact and use the different services within your account.
Brendan, based on your explanation of Oracle security offering, you or Creighton, can you guys comment on how Oracle helps from the security posture for the workloads deployed in OCI?
Yeah, I'll jump on that. I think, one of the nice things about the cloud providers in general is that when you move workloads there, they assume, so in this case, Oracle will assume, sort of all of the traditional physical security controls. So you don't have to worry about camera security and proper access control into the data center, because we're handling that for you. We've set very strict standards across not only us, but sort of everyone that we work with, that will help kind of enforce those policies and make sure that only the people that have access to come in and say change a hard drive are authorized to do so. From there, we move up the stack a little bit. We are ensuring, sort of accountability and security for the hypervisor and all the underlying components. And then we present you with a set of services that are very granularly defined from a zero trust perspective. So defining access or defining a service in OCI comes with no default access. You have to explicitly allow it. And that basically means that you whitelist only the access that is required for those jobs and integrations. From there, also, every single service that is running an ACI or OCI is an API. From there, that API, all those calls are logged, and those access controls in terms of who did what when are visible to you through the audit service. And that can be integrated with all of your security tools as necessary or visible through the console. So we very, very closely control access, but also from there, we make it very clear so that you can see what access has been applied and give you the ability to control from an encryption perspective, access to your own keys or keys that we manage. So from that perspective, it's very broad, but we've given you kind of that granular lockdown control. So, whatever you want from a data security perspective can be enabled and controlled at a very, very, very granular level.
Thank you, Creighton.
All right, so now we'll talk about compartments. And essentially a compartment is a logical collection of related resources, mainly for identity and access management purposes. As you can see here, like we discussed, you have your tenancy level compartment, and this is going to be referred to as your root compartment. And then all of the compartments that you create are going to be within this compartment. These compartments are hierarchical and they can span up to 6 levels deep. This is an example of what your compartment structure may look like. You can usually, you can organize your resources by environment or by team. Typically, I see it organized by environments. As an example, you may see, a development compartment where your development resources are running, and then, a UAT compartment, a production compartment, and you can kind of isolate your resources that way. But you can also set it up by, team. In this example, we have different teams, like your infrastructure team, applications team, information security. So, you really have the flexibility to structure it the way that you want to.
Yeah, and this is something that customers struggle with when they come from other hyperscalers like AWS, for example, because this is really all about, sort of IAM or security and permissions blast radius. When I say blast radius, I mean kind of preventing unintentional access to data, either, intentionally or unintentionally or maliciously, right? So when you look at kind of that ultimate boundary, it tends to, on AWS, for example, be the AWS account level, which means you can do some conditional access policies within the confines of the AWS account. Say, I want to allow this resource to do this, but when the tag equals this. But then you still have to allow the users to apply those tags. And there's nothing inherent in AWS, for example, that can sort of enforce the integrity of those tags. Like, for example, the cloud provider isn't going to know if me as a developer is on team A or team B. So I can say, I need to enforce what team are you on from a tag perspective, but it doesn't really care whether or not I select team A or team B. It only enforces the fact that the tag is present. So from there, what tends to happen to ensure that there's no unintentional access is you create another AWS account, which means then you spin up a multitude of accounts to provide that blast radius. And so it can get a little complex to manage at scale. The compartments in OCI provide that AWS blast, or that blast radius from an IAM perspective, so that you don't have to scale out your account structure. You can kind of keep it there and provide inheritable permissions at a very granular level. So it simplifies the kind of run and maintain aspect of cloud operations.
Yeah, thank you, Creighton. All right, so now we're going to look at IAM, or Identity and Access Management. So this visual here is a high level on how our identity and access management service works. Essentially, you have a user. When you create a new user, they're not going to have any permissions or privileges. Essentially, when you create a new user, all of their permissions are going to be denied by default. You're going to want to assign them to a group. And then from there, you're going to write a policy statement that references that group and also the compartment that they're going to be working in, and then the resources that they can interact in. We also have an instance here. So if you wanted to, you could set up a dynamic group that allows your instances to act as principal actors. And then from there, you could create policies to permit compute instances, as an example, to make API calls against other OCI services. And we'll take a look in more detail on what the policy syntax looks like.
Brendan, before you run into the policies, right, I think many customers, right, in the industry have already a user repositories or user directories, right? Like, how does OCI provide services to use the existing user directory?
Yeah, so we support, definitely we support, federation protocols like XAML and OpenID Connect. If you're using Azure, you can definitely federate. There's a short process called federation trust that you would go through to, create that connection. And then from there, you can map your groups that you have created within your identity provider to the groups that are within OCI. And then you can use your existing IDP to manage identities.
Thank you, Brendan.
Yeah, and to kind of jump on that as well, the nice thing is here, this policy language is very easy to understand. It's very plain and simple, right? This is fairly straightforward English that you can look at and say, oh, well, I understand not only who is doing this, but also what and where. Whereas, if you've ever had to look at complex JSON policy documents, it can be a little hard to actually suss out what the actual, result of that policy might be. So I think it's really interesting that we've provided a policy language that is super easy to understand. And then also, upstream federation gives us the ability not to manage those users in two places. So go with your safe source and federate from there.
Yep. And another look at the policy syntax. So when you build out your policies, we have this policy syntax here. So you're going to allow a group that you specify to manage, read, use, or inspect. You'll give it a verb. And each verb has a different level of access that can be seen here. Next, you will specify the resource type. So you can specify the aggregate resource type or the individual resource type if you wanted to get more specific with these policies. And then you specify the compartment that you want, the users to be working in. And then you can also have a where condition at the end. So if you wanted to specify a tag or, a specific type of action, you can get more granular with these policies. There's also a policy builder within the OCI console that's going to help you build out many common security policies. Essentially, you can go in and, enter what type of resources you're going to be working with. As an example, compute instances, you would select that from a list. And then from there, it can generate many different security policies that you would need to interact with those resources.
Thank you, Brendan. Now, from the networking side of the fence, right? I think depending upon the workload you have, OCI also provides you a lot of offering for you for the software-defined networking. How can you segment your from a network perspective? How can you make sure whether it's workload perspective or you want to segment the network so that the perimeter becomes reduced so that you can safely guard your private resources and then not exposed to the internet, right? So OCI provides you the software-defined network. We call it VCN or virtual cloud network, which provides you to create the network, and the subnet provides you the segmentation. You can create private subnets or the public subnets. In addition to this, we provide a lot of gateways for you to communicate between the external world and also for the private subnets to communicate to download the patches from the internet. So the gateways, we provide you our service gateways. I'll talk about that in the demo as well. On the bottom side, I think to deploy any application workloads you're required to front end, we highly encourage you to, for your application workload to front end with load balancing. It provides you a complete abstraction, high availability, so that you don't have to worry about the load balancing, scaling up and all those things. The load balancer automatically uses the algorithm, whether it's round robin or geolocation, and routes the traffic based on the available, the backend servers. The fast connect, I think most cloud vendor, customers are right now taking a journey to move into cloud, and they are they want to retain some portion of on-prem, and then I think transition to cloud in that journey. Or maybe you can decide I want to still stay back as an hybrid model, some in on-prem world and some in cloud. Fast Connect provides you to extend your on-premise data center into the cloud as one bigger network, so that you can use your private IP addresses to connect between the on-prem world and the cloud world. So Brendan introduced about a sample architecture we have been showing in this session. So I'm going to develop that basically from a network side of it. You can see that on the left-hand side, as Brendan talked about, IAM, and then all the security components are already present. As we build upon it, this view showcases a region which has got 2 availability domains. So we can create a VCN right now. And if you can see here, the VCN is created. It's a region-wise, so that you don't have to worry about it. It covers the 2 availability domains. And then the only difference here is in on-prem world, we used to create /8s. Right now in cloud, the maximum we can create is /16s CIDR blocks. And you can see in this diagram, we have created 3 different subnets depending upon how we want to deploy our workloads into each of the subnets and make sure the segmentation is there. From the security perspective, we are segmented. It's not a flat network. So the public subnet provides you a capability to talk to internet. Private subnet is completely guarded from the internet access, so that I think you can deploy your secure resources like in our application servers, the databases in the private subnets, and the load balancers in the public subnet. Okay. In fact, we are going to showcase how to deploy a load balancer here, and then I talk about the compute section. I'm going to dive into the private subnets deployment.
Yeah, and just another real quick takeaway on that. The subnet is the routing domain boundary. So you have a route table that is defined at a subnet level. So you can have multiple subnets and they can share the same routing table, or they can be different. Say, for example, you don't want subnet 1 to talk to your on-premise environment, but private subnet 2 you do. You can actually get very granular with that configuration as well. So those route tables have to be bound to a specific subnet. And there are generally some differences, like a public subnet is going to have routes to and from the internet. The private subnets will be just that, completely private, no access from the internet. But you can define maybe one of your subnets needs access to a NAT gateway to go out and pull patches from an internet hosted repository. You can do that, but only allow it for the private subnet that actually needs it.
Thank you, Creighton. Now, in terms of like compute, right? Any workload you want to deploy it, you want to use compute services like on OCI, and Oracle does offer wide variety of compute options depending upon your needs. Like I'll start from left to right. Like bare metal, when you want like higher cores, like a lot of performance, amounts of memory, you definitely want a dedicated physical server. Oracle does offer bare metal. And of course, the most popular right now is the virtual machines with like virtualized, where you do not need the dedicated server, but you can virtualize, use it. And then Oracle offers a wide variety of options for, in fact, I'm going to show you in the demo about how you can customize your cores, memories, and you don't have to pick a t-shirt shape, which Oracle offers a flex shape so that you can, depending upon your needs for our applications. And of course, if you're using microservices or other types of workloads, you can use containers and functions for your use cases as well. Now, again, building upon what we have discussed earlier, right? We brought in the load balancer into the public subnet, and now we are going to deploy the web applications into the private subnet, as you can see in this slide. So we are deploying the two different applications / web servers into the private subnet, being load balanced by the load balancer at the front end, so that I think you completely take the access from the internet to the application servers very well guarded from the security perspective. Load balancer is only available from the internet, and if you can see on the left hand side, there is also a web application firewall being front ended with the load balancer, so you can protect the load balancer from the DDoS attack or cross scripting and all those things, so that it is very secure. The network segmentation helps you to reduce the attack perimeter as well.
Yeah, so it kind of goes back to what we talked about earlier with the off-box virtualization, right? You're taking this load balancer, which is a purpose-built sort of instance that's going to be designed to handle that load of traffic, so it will scale more easily and more effectively. So you don't have to worry about adding Nginx servers to a pool or anything like that to make that work. It's a click button load balancer that can deploy and attach WAF to it directly, so that you don't have to worry about kind of that additional security. It's kind of taken care of as part of the platform.
So the another core services from OCI, we talked about net security, we talked about the networking, we talked about the compute. The other two very core services which OCI offers is one is the storage, and then I'll talk about the database before I jump into the demo. Now, in terms of storage, right, I think different types of or OCI offers, again, the best of the breed, different types of storage based on your needs. Like, if you are very memory intensive and you want to have a high old performance workloads, big data workloads, generally you go with local storage attached to your compute, where NVMe SSDs, it provides up to 54 terabytes. And if your use case allows you to share a particular sort of content across multiple instances, good olden days, we used to have an NFS mount for libraries, which we used to share across many compute instances. Oracle also provides you an elastic file storage for you distributed, and then you can use it like a SAN-like features. Typically, I think most compute instances uses block, so that you have some sort of storage for your workloads running on the compute. Block also provides you a lot of advantages for a local storage if you're 60 IOPS per gigabytes. And if you want to have a unstructured data like logs, videos, images, or anything you want to dump it, Oracle provides you very similar to S3, like an object storage, which is triple mirrored, and it provides you sort of like a distributed HA, also tiering in terms of store from a storage perspective. You don't have to pay for high usage costs, like, you can tier it, archive the data so that you can pay for what you use and what you access it. So object storage provides you like really the high availability and as well as the sort of like cost managed storage options for you. Now, again, building upon it, same example which we are storing right now, we had the compute instance. I want to bring in the storage into the example so that we can showcase like, storage can be used. If you look at in this diagram, I'm showing you, I'm on the right hand side, look at the object storage, which has been mapped. Now, the service gateway is one which is attached to the object storage. One of the key feature of the service gateway right now is it provides you an access to the object storage over the Oracle backbone. So a typical use case, which I think in many of the industry is, you have a storage where you want to not go over the internet because it is a risk of like, attacks or like, data loss, right? You're like, you probably might have heard about a lot of DLPs right now in the industry. Now, what we want to do is make sure that if you have a database and you want to back up your database backups to object storage, I think you go through the service gateway so that it goes over the Oracle backbone, reduces your risk, and also it is all over the encryption so that it doesn't traverse over the internet. It goes over the Oracle backbone. That's one key advantages. Now, the last component which I wanted to talk about it before I jump into a demo and showcases the Oracle console and other components which we discussed about it is database. Like, as you probably have heard about, Oracle is the industry leading offering databases. And I'll start with one of the most popular one right now. It is Autonomous. I think we have taken a lot of in the research and the experience for like over 2+ decades and built up this Autonomous database. What it provides you a lot of features, whether it is the transaction processing or the data warehousing processing, is it provides you auto scaling options. In good olden days, we have to probably like anticipate or guess, like, this is the type of risk, like, the OC, the course we want, this is the amount of memory we need, etc., etc. And then when actually the demand overshoots whatever they anticipated the resources, we had to take a quick action to bring it in the other resources. In terms of Autonomous, right, it automatically takes care of scaling. In terms of patching, it tunes it auto patching. So a lot of these things which was like, manual, and then a lot of guesswork. I won't say guesswork, but I think on demand, we have to take care of actions is all taken care of by the system itself, so that you have more time to work on other things. So that is fully managed for you. So it provides you a lot of features as I talked about it. If you still want to move towards the left, semi-managed, the Exadata is our like industry leading offering as well, which provides an extreme performance with the hardware and the database, tightly coupled and built in to run the highest performance for the database workloads. So you can provide you the full rack, quarter rack, or half rack, depending upon your use cases and also needs from the business perspective. And then far left, I think if you have used to managing your own databases on a virtualized hardware or on the dedicated bare metal hardware, you can still choose the Oracle database, and Oracle database comes with the same features as being run on the other two workloads.
Yeah, and that's really the highlight here, right? It's all about choice. So you can host that workload in whatever permutation works best for you, right? So if you want to do it the old traditional way, run it on infrastructure as a VM, absolutely. If you want kind of a little bit of guardrails, you've got these managed services in the middle. And if you want sort of that full self-driving mode, that's where the Autonomous will come into play.
Yeah, and Anand, can you explain the difference between ADW and ATP? I see those both listed there.
Sure. In terms of the ATP is a transaction processing database. Typically, popularly, the data is stored in a row format, and so that it is much beneficial for the transaction processing. And in terms of where ADW is the data warehousing option, where it provides you for the analytical workloads where you want to quickly run a lot of huge queries, like always stored in a columnar format, provides you a lot of performance to quickly query it and then provide you in the dashboard. So the the Oracle does like optimizes depending upon the workloads, whether it is ADW or ADT, depending upon your needs.
Awesome. Thank you.
So again, moving on an example, I want to bring in now, I talked about the database. I want to bring in the database into the mix. And as you can see here, like right now, the architecture shows complete deployment of an application, like, starting from a load balancer, we had the 2 application servers connected to the database. And then, of course, if you can see that on the left-hand side, there's an analytic cloud service pulling up for the reporting purposes, the data from the database. So a simple view about the a simple web application or an application deployed in OCI, including all the security items on the left-hand side, whether you want to have a WAF in front of the load balancer, or on the other things like, Cloud Guard to analyze, like, how is the security configured and everything, all within this network segmentation between the private subnet, public subnet under the software-defined networking VCN. Okay, so we covered the core services. As I said, the second row, which I think compute, storage, networking, databases. As you can see from this slide, right? OCI provides you a broad breadth of services in the cloud, like, from an Oracle applications, custom applications include ISV applications. Highly encourage you to take care of it depending upon your business needs as well as requirements. We have a broad breadth right now in terms of, like, your cloud needs. Okay, so what I'm going to do right now is I'm going to start sharing my screen, and then I'll quickly walk you through the remainder of, like, next 10 to 15 minutes about a walk into the Oracle console, take you through the journey of creating a software-defined networking and deploying a simple compute instance, and then we can open for Q&A. Hopefully you all can see my screen. Let me go and so I've already logged into the Oracle console. As when you log into the console, you can see this, like, it provides you, like, a links, which is you can see what I've recently visited, and some of the quick starts are already provided here so that you can take a look at it depending upon your interest. Other thing is, like, if you want to customize your dashboard, you can use that, like, if you have a responsibility of taking care of billing, you can add a billing widget. If you are in an operation side of the fence, you can add monitoring, logging, and then other resources, you can do it. You can add the widgets here, so depending upon your needs. On the other side, if you just want to go out and explore OCI, there's under this hamburger, you can see that I talked about compute, storage. Like, on the compute, you have, like, a lot of different options for you, like, instances. You can see that what all the other like, needs, you can do it in the compute side. From the storage side, I talked about block storage, file storage, object storage. You can use all those things. I'll dive into the networking in a minute. But before that, I want to also talk about Oracle databases. You can see that I talked about autonomous, both the autonomous data warehouse as well as autonomous transaction processing. And then I think you have other services, like, Brendan was talking about it in earlier, identity and security side of the fence. You can see that you can create users. You can also do the federation if you already have a user repository, so that you can create a federation so that you can use your existing Active Directory or any other user repositories which you have. So security side of the fence, you can see all the things like, firewalls. We have network firewalls. We have web application firewalls. We do offer, like, other things like Cloud Guard. So we do have a complete breadth of security offerings. So take a look at it, identity and security. In terms of observability and management side of the fence, like, if you want to monitor something, you want to do a logging perspective, you want to do log aggregation, like, we do also have a barebone log aggregation service, like, you do have, like, logging and logging analytics, etc. last but the least, I think the billing side of the fence, like, if you want to make sure that how do you run the invoices and look at that invoices, and then what is the burn rate and everything, we do have also the billing and cost management. Now, from the network perspective, what I would like to do, the goal of this demo is I want to showcase to you a simple a deployment of a compute instance. I'll start with the networking. I talked about the virtual cloud network, and I talked about the load balancer. So let me start creating a software-defined network networking using a wizard. So a wizard provides you a very easy and in 2 steps, you can create the software-defined networking. I highly encourage every one of you, if you get an access to a tenancy, to try out how to create a software-defined VCN. So if you look at the wizard, what it does is it automatically creates, like, I'll just do a name, day 1 and beyond, or a day 1 and VC. I'll just name it as VCN. And it allows you to choose the compartment which you want to deploy create the VCN in. It has default created the CIDR blocks for you, /16, and subnets. If you need lesser number of IP addresses, you can go into /28. Okay, you don't have to take the defaults. If you want, you can go lesser. And then if you look at it, everything else is automatically taken care for you. If you click next, the public subnet it is creating, the private subnet it is creating. As Creighton was talking about, there is a route table here. You can see the route tables here, one for the private subnet and one for the public subnet, because it uses the different route table. Additionally, it has also created the gateways for us. Like, if you look at it, the internet gateway is used by the public subnet. The NAT gateway is used by the private subnet. And NAT gateway is traditionally used to go outbound the traffic to the internet to download the patches or any libraries which is needed. But generally speaking, it is very tightly restricted. And then I think service gateway again is connected to private subnet, which I talked about, a use case where you have a database in a private subnet and you want to copy the backups to the object storage through the service gateway. Okay. The other thing which is also creating is the security list, which is nothing but, think about security list like a firewall. If you want to control the north-south traffic, you generally use firewalls in most companies like Cisco, Meraki, Palo Altos, et cetera. If you want to control the east-west traffic within the VCN and within the subnet and everything, you have 2 choices. One is the security list. Other one is, if you want a granular, VNIC level, you can also use network security groups. Okay.
And one important thing about those two is that both of them contain rules which will allow traffic. An interesting differentiator between OCI and maybe some of the other cloud providers that some of you may be more familiar with is the fact that if it's allowed in one, it's allowed in both. So the evaluation of these rules is the union. It'll look in the security list and the security group, and if it sees an allow, it'll be allowed. Whereas, I've seen customers kind of not expect that behavior, because the comparison in AWS would be a NACL, and a NACL would be, it's allowed here, but if it's not allowed in the security group, it's not allowed. So it becomes a little bit different evaluation. So something to be aware of when you go through here is that you need to check both and make sure that you're not allowing unintentional traffic.
Thank you, Graydon. And when I click a button create, it takes less than 30 seconds to create that. As you can see that typically 20 to 30 seconds and you're done. You have the VCN already created.
So you told it to create a VCN, and it figured out what dependencies you need and is deploying them, and it's all done through the GUI. This same functionality can exist with code like Terraform as well. So you can kind of automate that deployment and deploy it across the globe with a single Terraform apply, or through the GUI, depending on what you're most comfortable with.
Thank you. And if you want to quickly view this, what I created a day 1 VCN is, as you can see, it created the two subnets. The one is private subnet, the other one is public subnet. It gave you the CIDR blocks. I changed it from 24 to 28. And you can see that the internet gateway is also created. The security list is created for both the subnets. I'll quickly run through the one of them. So if you look at it, there is ingress rules and egress rules. Ingress rules is what you want to allow to incoming traffic, and egress is what you want to allow to the outbound traffic. Generally, outbound traffic, most general rule is to allow everything to go outbound unless you want to restrict the outbound communication to a particular transit, sort of like a gateway, and then and check the outbound to the through a firewall. You can certainly do that through a route table so that you can route all the traffic to a particular transit gateway, and then I think and get out of that. In terms of other things which is there here is like, I talked about the NAT, I talked about the security and the route tables. So you can certainly do, you can create the dynamic routing gateway if you want to make sure you want to integrate with your on-premise network with the fast connect as well as the DRG, and then bring and connect to the OCI. So you can certainly do that. Now, what I'm going to do in next few minutes is I'm going to take this and deploy a compute instance into the already created VCN. Okay. Now, as I said, go into the compute instance and then click on the compute instance here. Now, as you can see here, I'm right now in a same compartment. This is the customer's compartment, which I created the VCN in. And I'll click on create instances. You can see that there's many of the, on the left-hand side, auto scaling configurations, cluster, instance pools, etc., etc. I'm going to only focus on creating the instance. Now I'll give you an example of this name as well as a day one instance, and then and that's all. I'm going to name that instance. I'm going to choose the compartment again. It is already default choices. I can still change the compartment if I want to. So it's customers. Now it is giving me an option of which availability domain I want to deploy the instance in. Okay, so it is like an availability 1 domain, availability domain 2, or everything. I'll choose 2. And if you can see also is the region is #1 availability 2, and it gives you an option of changing the image shapes. The one advantage is like, I'll click on this. So there is a lot of image shapes if you want, like, you want to go in and say that, okay, I want like, Oracle Linux. Now I'm going to run CentOS, or I'm going to run Windows. It gives you an option to change the Windows. I'll keep the default right now. Then I think in terms of image, I choose the Oracle Linux. Now you have the opportunity.
Sorry, Anand, real quick. There are also partner-based images as well for things that aren't standard operating systems. So maybe some of your firewalls or other things like that are available in another tab in there. But so it's not just limited here, but the possibilities are quite literally endless, because you can also bring your own images.
Agreed. Thank you. Thank you, Creighton. So in terms of the shape right now here, right, you can also change the shape here, right? So we have many shape series offering. We offer Intel, AMD, and in terms of like, right now I've chosen AMD, and the shape name is E4 Flex. And the one advantages in this is like, as I was talking about, like, you don't have to worry about like, a t-shirt shaped sizes offering. You can customize it. For example, if you want like, 3 CPUs, and then like 9 GB or like 16 GB, which is like odd requirements. If you wanted that, you can certainly customize it. Like I can take it like say that 4, and I want the memory to be like 32, right? You can certainly do that. Okay, so sometimes I think it is heavily, let's say, core centric workload, but not that memory centric. So you can make it 6 and 32. So it gives you a flexibility to change depending upon your workload. So I'm going to select the I'm going to make it I'm going to select the shape. And then I think in the terms of networking, it's, if you look at it, since I have the only one, you can create a new cloud network again, or you can use the existing one. I'm going to use the existing one, which I created in the previous step. I'm going to deploy this instance in the private subnet rather than the public subnet. As I said, it is always better to deploy everything in the private subnet and only deploy certain things which needs the internet access in the public subnet. Okay. Now, it doesn't need to assign a public IP address because it's in private subnet. If you have your own SSH keys to access it, the instance, since it's a Linux instance, you can do it or generate the key and download it. I'm going to generate it right now. And then if you look at it, like, from the boot volume perspective, I don't have any special thing. I can create the instance. If you think that this is a configuration which you want to save for a future future creation, you can save it as a stack and come back and recreate the same configuration so that you definitely get a same amount of configuration all the time, right? You don't have to keep doing it manually. You can save it as a stack and create it from the stack, okay? And I'll create it. And if you look at it, it takes about it's already creating, it takes about less than a few seconds, 15, 20 seconds. And I think you should have the instance up and running. It's provisioning the instance right now.
Yep. And then as it builds, you'll start to see the things like IP addresses and stuff populating, and you'll be able to start accessing it pretty quickly. There is, I think, in here too, console. So you can get the virtual machine console. And there's also, I don't know if we've talked about it, but the Bastion service would be available to maybe SSH in if you don't have a fast connector or VPN too.
Yeah, it's running. So I think it took less than a minute to get the instance running. And then I think as Creighton was talking about, right, you can see the IP address and all those things already populated here. And then if you can go down here, you can see the work request, and you can click on this and then see the details, how it ran the every command and everything. And last but the least, I think I talked about the private subnet it deployed in. Here is the IP address, which provided to this instance, because I choose the private subnet. And then if you can see the image details here, I choose the Oracle Linux image and et cetera, et cetera. Its shape also is customized shape. I created a OCPU 1 and then memory as 32. Okay. With that, I think I want to make sure we have time to close. And I think, and here is the one more thing which we wanted to talk about. It is if you need any resources on terms of training, live labs, or hands-on experience, we highly encourage you to take a look at it after this training. And if you have feedback, please let us know. Back to you, Renu.
Thank you, Anand. Great session. Really liked all the interaction that's going on here, and we have a lot of questions. We still have 2 questions in the Q&A panel, if someone can look at it. Anand, Brandon, Creighton. So with that, I would really like to thank Brandon, Anand, and Creighton for kicking off our season 4 of Day 1 and Beyond series. It was a great session, like I said before. I'm sure everyone had a great learning experience. The replay and PDF for this event will be available on the Customer Connect forum, so feel free to share that with your friends and colleagues. And if you want to refer back to content at any point, you will also receive that link in a thank you email that you'll receive from us. There are more sessions in this series, and I hope that everyone can join us again. Our next session will be on OCI Analytics, so please join us again on Feb 7th. Mike, can you put the last poll for everyone over here? Thank you so much. And Anand, you had a resources slide. I would like everyone to see what we have, and I will also post those links in here. Anand?
Yeah, I'll keep resources slide.
Yeah.
Yeah, and Creighton, I'm not sure if you know this off the top of your head, but it looks like there's a question about the number of sessions in relation to ATP. And I think, when it comes to the concurrency setting of low, it's like 300 sessions per OCPU. Is there any way to increase that?
So I'm not a database expert per se, but I'll make a theoretical comment here, and then we can do some research and get an answer to that. But it's not necessarily just utilization. There's overhead in establishing sessions and managing sessions as well. So if I were to make an assumption, it would be that limit is probably in place to prevent the sort of ins and outs of session management from affecting database performance.
Awesome.
Okay.
Thank you, Creighton. I have posted some links here. Feel free to copy paste these links, and I will ensure that you also get a copy of these links in the thank you email that you receive. With that, thank you so much for joining us, and we'll see you next time. Thanks a lot.
Thanks, everyone.
Thanks all. Have a great day.